Hello and welcome to the BMC Quick Course Series. My name is Andy Andrews and I'm a software consultant for the Mainframe batch products at BMC. BMC Application Restart Control, also known as ARC, uses checkpoint restart logic to automatically restart failed job steps and save significant amounts of both time and money. ARC is available for Db2, IMS, and vSim batch environments. For a program to benefit from ARC, it must have a checkpoint restart capability. In other words, checkpoints. Many programs, including Db2 batch programs and IMS BMPs, already have checkpoints or commits coded in their logic. ARC can convert existing checkpoints and commits to ARC checkpoints. Db2 commits and IMS checkpoints are focused on the database elements within their respective DBMSs. ARC checkpoints have a larger scope and encompass both DBMS and non-DBMS related elements to obtain a more complete picture of the execution environment of the batch program. Now let's dig a little deeper into what actually goes on during a checkpoint. A checkpoint contains all the information your application program needs to resume processing after an abend. The checkpoint captures the contents of program storage to preserve the value of various accumulation fields such as the total input record count, and it captures the information needed to reestablish database position. Finally, ARC captures the position and state of all flat files. The checkpoint physically logs updates and flushes data buffers to harden the data onto the actual device. Part of the logging action is to write the commit record to the log. After all of this has been completed, any logs held within the DBMS are released and the associated data blocks are now made available to other concurrent processes. ARC supports checkpoints for many DBMS environments. In most cases, the scope of the checkpoint is expanded to include non-DBMS data that is associated with the application at the time of the checkpoint. The auto checkpoint feature of ARC was designed to easily add checkpoint restart logic into a COBOL program that does not already contain checkpoint code. Auto checkpoint makes it possible to externally define a logical unit of work boundary, often without requiring a compile of the program. Auto checkpoint is a COBOL-only feature and is applicable to the IMS, Db2, and vSim environments. When a batch job fails, you generally recover the affected database, back out all of the changes made so far, and restart the job from the beginning. This takes time, manual effort, and up to double the CPU usage that a successful job would have taken. In the example here, a job that normally runs 5 hours could take up to 16 hours to complete. ARC provides a checkpoint restart logic for batch programs. In other words, ARC inserts checkpoints or commits at specified intervals. If the job fails, ARC can restart the job from the latest checkpoint, so you don't need to run the job from the beginning. With ARC, you don't need to recover the database or back out any changes. ARC simply restarts the job from the most recent checkpoint and the job continues as if nothing had happened. First and foremost, ARC is a restart product. The main goal of the product is to provide an environment that will support checkpoint restart across many potential application environments. When a job step abends, the restart process is very simple. You simply restart the job at the failed step. ARC then takes over and performs a more granular checkpoint restart at the last completed checkpoint. During restart processing, the input and output files are repositioned and set to their state as of the last checkpoint. The application program is loaded into main storage, but before control is transferred to the application, the contents of program storage are overlaid with the copy that was captured during the checkpoint. Now that the execution environment has been reconfigured to support a restart, ARC then transfers control to the application program and execution will begin at the top of the program logic. Checkpoint processing is an absolute requirement for batch processing in a shared database environment. Adding checkpoints to a program execution will not help the program run any faster, nor will the program do its function any better. From the point of view of an application program, checkpoints are 100% overhead, both in terms of resources consumed and elapsed time. In a perfect world, a program will issue a minimum number of checkpoints, but at an interval that would 1. Satisfy restart requirements, and 2. Minimize the number of concurrently held DBMS locks to enable shared processing. In the less than perfect world that we live in, this rarely happens. Checkpoint intervals are seldom regulated in a program, and typically little thought is given to the current checkpoint interval after the program has been placed into production. Many of the programs we run today were originally developed more than 20 years ago. In addition, they were developed to run on hardware platforms that are much slower than the current generation of hardware and software that we now run. As years of successive hardware and software upgrades are rolled out, the processing rate of an application program gets much faster. Yet, few people go back and recalibrate their checkpoint intervals for each upgrade. The result we see is a natural shrinking of the checkpoint interval. What once may have been a 2-second interval, over time evolves into multiple checkpoints per second. Taken to the extreme, some programs issue upwards of 40 checkpoints per second. Arguably 80% or more of the total processing in support of these applications is devoted just to processing checkpoint requests. ARC has the ability to filter out excessive checkpoint activity without having to modify an application program. The filter sits between the application program and the underlying DBMSs. If a program issues checkpoints too often, they are simply intercepted and sent back to the application as though they were processed. This way the application program can continue to execute. Periodically, a checkpoint will be allowed to pass through the filter and it will be processed normally. The net effect is a significant reduction in overhead in both the application program and on the DBMS. Thank you for your time. For more information on any BMC mainframe product, please visit the URL shown here.